Okay, this is pre-AP geometry 4.5, triangle congruence for angle, side, angle, 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 side, and hypotenuse leg. So before we jump into the lesson, let's just do a little bit of review. When we cut out our triangles the other day, we had 5 ways that we determined that we could prove that two triangles are congruent. And those were angle, side, angle, side, 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 angle, side, angle, angle, side, and hypotenuse leg. And there were 2 ways that we determined would not work, and those were angle, 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 which we could remember by thinking, if you have to call AAA, it means it's bad news for your car, you know. But I more or less like to just say, ah! We can't use that one, all those A's. And then the other one that we cannot use is side, side, angle. And we know that when we read that backwards, it makes a bad word. It's just not going to be used. So, so these are the 5 ways. And we have already discussed 2 of them, and we have remaining today angle, side, angle, 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 side, and hypotenuse leg. Okay, so before we talk specifically about angle, side, angle, we want to write down a definition of an included side. Now, on our previous lesson, we talked about an included angle, which was an angle that's shared by 2 sides. In other words, it's the angle in the middle. This time, the included side is going to be the common side of 2 consecutive angles. Of a polygon. So again, like before, it doesn't necessarily have to just be for triangles. This definition is the same for all polygons, but of course we're looking at triangles in this unit. So let's just take a look at the example here. Which one of these is the included side for the following angles? So if we're talking about angle B and angle A, here's angle B, here's angle A, which side is the included side? The side that's shared by the 2 angles, or another way you could think of it is the side that's in between them would be line segment AB, or we could write it BA, either way. And then let's look when we have side or angle C and angle A. The included side would be this side right here, and so that would be line segment AC, or we could write it CA. And then finally, if we have angle B and angle C, our included side is going to be BC or CB. Now, it's important that you understand this idea of an included side, because when we get to doing proofs, you want to make sure you're using the right reason for your proofs. Is it, you know, angle, side, angle, or is it side, angle, side? You know, which way is it? So make sure you understand which side is the included side, or which angle is the included angle, as the case may be. Okay, so let's do the definition of angle, side, angle. I shouldn't say definition, but this is the postulate. If 2 angles and their included side in one triangle are congruent to two angles and their included side in another triangle, then the triangles are congruent. Now that's a lot to write down in a proof, so we get to just say ASA when we're doing proofs. So let's look at the two triangles that we have here. Okay, so let's look at our drawing. We can say angle A, I'm going to do a different color. Angle A is congruent with angle D, and if side AC is congruent with DF, and if angle C is congruent with angle F, then we can state that triangle ABC, I'm doing that alphabetically, is congruent, and then we want to make sure the other one, when we write it down, lines up. We started with A and we went to B, so we're going to start with D and go to E. It's important when you're doing these that you put them in the right order, or you'll get it wrong on quizzes and tests, because you have to, the angles have to line up when you name your triangles. So triangle ABC is congruent with DEF, and what's our reasoning, or how can we justify that? By angle side angle. Now, where on those two triangles is the included side? And I hope you can see that it's this side. This is the side that is shared. It's the common side between the two angles. Okay, so we're going to go down here and do this proof on example 2. Okay, so as we do this proof, I'll tell you what, why don't you try and do it without my help? I think you could do it, so I'll get you started. I can mark that angle D is congruent with angle C. Given. And we can say that DB is congruent with CB, given. So we're going to mark that on our deal. And we want to prove that triangle ABD is congruent with triangle EBC. So I'm going to stop right there, see if you can fill in the last 3 parts. Okay, so let's see here. We can say that angle ABD is congruent with angle EBC. ABD, right here, this angle, is congruent with EBC, which is this angle. Now, and the way the proof for that would be all vertical angles are congruent. Now, an important note, this is very important for this statement right here. You cannot say angle B is congruent with angle B and use the reflexive property. It doesn't work on this one, because if you'll notice, there are 4 different angles where B is the vertex. We have angle ABC, we have angle CBE, we have angle DBE, and which one did I miss? EBC. So you can't use angle B, because we don't know which two you're using. Is it, if I said this, and if I just said angle B and angle B, we could potentially just mean this angle B and this angle B, and they're obviously not congruent. So you have to name the angle using B as the middle one, as the vertex. So that's important. You'll get it wrong if you do this when it's this kind of an arrangement. Now, if there was a need to write the word angle A is fine. We can say angle A like that because there's only one place where A is the vertex, but angle B is a different story. Okay, so enough of that. And then our final statement is triangle ABD is congruent with EBC, and how do we know that? What's our justification? It is angle, side, angle. Now, remember, anytime we put a reason over here, it needs to be proved up here before we say it. So let's see. Angle D is congruent with angle C. That's angle. Segment DB is congruent with CB. That's your side. And then angle ABD and EBC, there's your angle. So we use statement 1, we use statement 2, we use statement 3 to do angle, side, angle. Okay, let's jump down to number 3. Number 3, you might want to put a little star on this because these are the kind of questions that apparently like to show up on semester exams and benchmark tests and that kind of thing. So let's take a look. It says, in the diagram, M is a midpoint of line segment PN. Which additional congruence must be established in order to prove that triangle PMK is congruent with NMQ? So hit pause, think about that, write down your answer, and we'll see how you did. Okay, so from the given information, because M was the midpoint, we know that PM is congruent with MM, so put my little congruence marks there. And angle PMQ and NM, let me say that again, PMK and QMN, those two angles are congruent. And so the two that we need in order to prove this would be angle P to be congruent with angle N. That's the other set of angles that we would require to be able to prove this. Now I want to ask you, why not angle Q and angle K? Well, in that case we would have angle, oh no, we could do that. Hang on a second. Okay, you could use that if it was asking you for angle, angle, side. But in this question it said it wanted angle, side, angle. So we have to use angle P and angle N. And then I did want to mention, unlike the proof that was above it, we can go ahead and name angle P by itself and angle N by itself because it's the only, there's only one place where P is the vertex and N is the vertex. So it's okay to name them as single letters like that rather than, like KPM, angle KPM and angle, M and Q. So enough about that. I think you get the gist on that. Okay, now the last thing I want to say is that we're not stating that these two triangles are congruent. What we're saying is that in order to be able to prove that those two triangles are congruent, we would have to be able to prove that angle P is congruent with angle N. So this is a condition to be able to prove those two. So unless there's some way to prove this, there's really no way to prove those two triangles are congruent. Okay, So we'll leave it at that. Let's go on to the next one. Okay, so on this next example, if I say if angle Q is congruent to angle X, and if angle P is congruent with angle W, and side PS is congruent with side WY, then we can say, let's see what we've got. We've got an angle, we've got an angle, and we've got a side. So we can say triangle QPS, that's in alphabetical order, and is congruent with, and we've got to make sure we start in the same place with this triangle. Q is the one with one line, so we want to start with the one that has one line over here, so that's going to be X. And then we went Q to P, so we've got to go X to W, and then Y, like that, so that everything matches up, and those two triangles are congruent by what justification? Angle, angle, side. Okay, now let's go ahead and write out the postulate for you. Angle, angle, side congruency is if two angles and the non-included side of one triangle is congruent to two angles and the non-included side of another triangle, then the triangles are congruent. And I want to change one bit of grammar. I said, if two angles and the non-included side is, it should have been are congruent, if they are congruent. So, whatever. So let's look at the example. Look at example 4, complete the following proof. I think you can try that on your own. Do that on your own. You can hit pause. I can, I'll get you started. Look, I'll help you out. Angle 1 is congruent with angle 2. Whoops. Okay, so there you go. I've helped you out on that. I put our givens and what we're trying to prove. So statement number 3. What are we going to say about that? Remember that we want to prove this using angle, angle, side, and so what do we know? We know that RM is congruent with RM. Oops, let me use a different color. And how do I know that? Reflexive property of congruence. And then what's our justification, final reason to prove these triangles are congruent would be angle, angle, side. And as always, we want to make sure those statements have all shown up previously in our proof. And so here's angle 1 and angle 2, angle 3 and angle 4. There's an angle, and then RM is congruent to RM. There's a side. So we've proved that in those first 3 statements. Okay, now I'm going to draw a little picture for you over here on the side, and I want you to take a look. I'll erase some of this. And so got this. And okay, now I want you to look carefully at the 2 sets of triangles and kind of figure out what is the difference about them. I'll ask you, are both triangles, sets of triangles, congruent? Are the blue set, are these 2 triangles congruent? And are the red triangles congruent? And we can say yes, they are. These blue ones are congruent by what justification? And you need to be careful. Let's look. We have an angle, and a side. It's the non-included side, so that's going to be by AAS, angle, angle, side. Whereas on the red one, these triangles are congruent. And what's our justification for this one? Angle, side, angle, because we have the angle, there's the angle, and the side is common to both angles. So angle, side, angle. Okay, let's go to number 5. Okay, so here's another one of those little kind of semester exam type questions. It says in the diagram, angle 2 is congruent with angle 3, so let's mark that. What additional congruence must be established to prove that triangle ADB is congruent with triangle CDB by using angle, angle, side? So hit pause, think about that, and see what you know about those triangles and see what we need to prove. Okay, so we also know, besides these 2 angles being congruent, we know that BD is congruent with BD because of the reflexive property. So let's see what we've got so far. We have an angle that's congruent. Angle 2 is congruent with angle 3. And we've got a side that's congruent. BD is congruent with BD, reflexive property. So what we need is another angle, and we've got to think about which angle it is will help us prove angle, angle, side. And it's going to be this angle right here, angle C and angle A. That's what we would need to prove in order to be able to use angle, angle, side. We can't use these 2 angles here because that would be side, angle, side, angle, different postulate. Okay, so the question's asking for angle, angle, side. So again, as we said in that other one, I'm not saying these are congruent, I'm just saying that's what we would need to prove in order to prove these 2 triangles are congruent. So that would be the other angle right here in order to give us angle, angle, side. Okay, let's keep moving on. Okay, so the next postulate we're going to look at is the hypotenuse leg. And so why don't you drop down here into this nice space that's at the bottom of your page, and let's talk about HL. Okay, congruence. And we say if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Now, there's some key things that we've got to talk about here before we get into the proof. First of all, let's just talk about what we mean by a right triangle. A right triangle has a right angle in it, and the legs, when we talk about a leg is one of the sides that's in common with the right angle. The hypotenuse is the side that's across from the right angle, and it's also the longest side. And in the hypotenuse leg postulate, we're talking about right triangles. Very key that it has to be a right triangle in order to use HL. And so somewhere in your proof, when we're doing proofs, you have to say, or maybe say, you must say, the triangles are right triangles. And in order to prove triangles are right triangles, you have to show that they have right angles. So really in your proofs you're going to have 4 steps in order to prove that 2 triangles are right triangles. You've got to say that it has a right angle and therefore it's a right triangle. It has a right angle, therefore it's a right triangle. Now, this particular postulate is a little different from the other ones because side, 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 angle, side, angle, side, angle, 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 side. They all have 3 parts that have to be proved, whereas in hypotenuse leg, we just have the 2 parts. Now, you might say, well, this would be an example of angle, side, side, angle. There's a side. If I said that's congruent, and this is congruent, and then you have your 2 right angles, side, side, angle, and I said this is something that can never be used. Well, the only exception would be right triangles, because right triangles are the only type of triangles that have a hypotenuse and they have that same right angle. So you don't have a hypotenuse in other triangles, only on right triangles. Okay, so we're going to go back up now to the top and do this little proof. Okay, so it says complete the following proof. Angle B is a right angle, angle D is a right angle, AB is congruent with CD, and then we want to prove these 2 triangles. So let's mark what we know. Angle B is a right angle, so we're going to put our little right angle symbol on there. And angle D is a right angle, so there's our little symbol. AB is congruent with CD, and then this was what we want to prove. Okay, so as I mentioned below, remember we've got to be able to state in our proof that triangles are right triangles. So let's start with this first given. Angle B is a right angle, and that's given. Now, as a result of that, what can I conclude? I can say that triangle ABC is a right triangle. And that A right came out looking like art. So let's try that again. Is a right triangle. Okay, and how do we know that? Definition of a right triangle. Right triangles have right angles. Okay, so then let's look at our other given. We have angle D is a right angle. given. And what can we conclude as a result of that? Well, we can conclude that triangle CDA is a right triangle. Now, what else do we know as a result of this picture? Remember, we need, for HL, we're looking for hypotenuse and a leg, and we already have a leg that's shown as congruent. Let's go ahead and add that. AB is congruent with CD. There's our leg given, and now we need to find a hypotenuse, and that would be right here. AC is congruent with AC. How do we know that? Reflexive property of congruence. And do we have everything we need? I think so. We can say triangle ABC is congruent with triangle CDA. And how do we know that? HL, hypotenuse leg. And remember, those statements have to show up in the proof. And so let's see here, an AB, there's our leg, and AC is congruent with AC, there's our hypotenuse. So we have statement 6, statement 5 is what helps us prove that by hypotenuse leg. Okay, now let's go to the back page, and we're almost done. Okay, I would like you to do all 8 of these problems without my help. So I want you to hit the pause button. You're going to state whether or not the two triangles are congruent, state the postulate or theorem that justifies the congruence, and then, what was I going to say? Oh yeah, and then if you can't, you can say no conclusion if there's no conclusion, if it cannot be determined. So try that out. Hit pause, do it without me, and I'll come back and see how you did. Okay, so on the first one, triangle BCA is congruent with EDF. How do we know that? Side, angle, side. And that's an included angle right there. That these angles right here. Side, angle, side. Then number 2, MOP is congruent with triangle AER by side, side, side. Number 3, DOG is congruent with TAC, and that's by side, angle, side. And I do want to mention, don't get suckered into saying HL just because you see a right angle. In this case, we have side, angle, side, because HL, you're proving that the hypotenuse is the one that's congruent, and in this case, that's not what was shown. It's the side, angle, side. Okay, and then finally on the fourth one, on these first 4, this would be no conclusion because we have side, side, angle, and we know who thinks that can be used as a postulate. You can't, because it's not. No conclusion. Okay, do the next 4. Okay, here's your answers. No conclusion on the first one. Or that's number 5. Number 6, AKM is congruent with triangle AKR based on side, angle, side, because we have this side that is congruent by the reflexive property. And again, reflexive property on number 7. And so we do HL, hypotenuse leg. And then on number 8, triangle BIE is congruent with triangle KEI, and that's by side, angle, side. And how do we know that these angles are congruent? Because it shows these lines are parallel right here, and so this is like a transversal, and so this angle right here is congruent with this angle right there. Okay, so we have a side, an angle, and a side. a side, an angle, and a side. A little messy there, but you get the drift, right? Put in little congruence marks there. Okay, so now your homework, I do believe, is out of the textbook. And have a great weekend. Bye. We'll see you in class.